All right. Today we're going to talk about pH and pH calculations. So first we're going to go over our learning target. And our learning target is to be able to differentiate between acids and bases in terms of the hydrogen ion concentration. Now, like we just talked about, you were talking about getting the pH at the pool. Okay? That pH that you get at the pool is just a number. And that number is based on the hydrogen ion concentration. All right? So we take that hydrogen ion concentration and convert it onto a logarithmic scale. And we're going to learn about what a logarithmic scale is here in a bit. Now, our success criteria is to be able to determine the pH, the pOH, the hydrogen ion concentration, and the hydroxide ion concentration. So let's look at this a little bit. Anytime we have these brackets around something, these brackets around the OH minus, that's the concentration of. Now, I didn't say this in my other classes, and they had a couple of questions. Sometimes on WebAssign, you're going to see this hydrogen ion concentration right there. You're going to see it written like this. When you see it written like that, you should just automatically think the hydrogen ion concentration. Okay? That is actually what we call the hydronium ion. And sometimes in some of the textbooks, they represent it as the H3O plus concentration, not the H plus. So when you see that on WebAssign, you're thinking H plus. Now, when we talk about the pH scale, we're going to talk about a logarithmic scale. And just there, the definition, it says it is a nonlinear scale often used when analyzing a large range of quantities. Instead of increasing by equal increments, each interval is increased by a factor of the base of the logarithm. Now, in this case, and like it says there, typically a base 10 is used. And that's what we're going to use here on our pH scale. Now, what does this all mean, this logarithmic scale? Okay, well, down here at the bottom, look at this. It says, for example, a pH of 3 is 10 times more acidic than that of 4. So, if I have a pH of 4 and I have a pH of 3, even though we're normally thinking those are only one number apart, well, that's telling me right here that 3 is 10 times greater, 10 times more acidic than 4. Now, what if I would have 5 here? Well, 5 and 4 and 3. So 5 is 10 times less acidic than 4. So how does 5 and 3 relate? Well, 3 is 100 times more acidic than 5. That's a logarithmic scale. Now let's think about this. What about 2? How do 5 and 2 relate? Matthew.
2 is 1,000 times more acidic than 5.
Excellent. 2 is 1,000 times more acidic than what 5 is. Now, when I come down and look at the pH here of a base, it's the same thing. Okay? A pH 10 is 10 times less basic than a pH of 11. So 10 compared to 11, 11 is 10 times more basic than 10. If I go from 10 to 12, it's going to be 12 is 100 times more basic than 10. So that's the logarithmic scale, and it's built on the number 10. Now, this is the very diagram that I had on the video notes from last night. Because when we do sig figs with these logarithmic scales, it's different. Okay? Now, what you have to remember is that pH and POH are both logarithmic scales. So, it's going to be different using the number of sig figs. It says, with logarithms, you count the number of figures after the decimal point. So, how many figures do I have here after the decimal point? Lena? 2. Good. I have 2 decimals after, or 2 numbers after the decimal points. So that's going to tell me that this problem is going to have 2 sig figs. So when I do my calculation for my hydrogen ion concentration, I need to have 2 sig figs. Now, is hydrogen ion concentration logarithmic? No, only these 2 are logarithmic. Okay, so I can use the one before the decimal. So there's my 2 sig figs. Does the 7 round the 3 up? Yes, it does. So there's my answer in 2 sig figs. Now, here's where it gets confusing. Look at this value right here. Hydrogen ion concentration is not logarithmic, is it? So how many sig figs do I have there? 3. So now I come down here and I calculate the pH using that value, and I get this value. Now, is that value on a logarithmic scale? Is it one of these 2? It is, isn't it? So that tells me that I only use past the decimal point. So I had 3 sig figs, so I need 3 sig figs past the decimal point. Does that 7 round that 5 up? It does. So my correct answer for this one, with 3 sig figs, is 13.676. The 3 sig figs are the 3 places after the decimal. So, when I'm using the values for pH and POH, I'm only using after the decimal for sig figs. I can tell you right now that when you do this WebAssign 12.2, the place you're going to screw it up is sig figs. Okay? You're going to mess up the sig figs because I see it all the time. I've already seen it today, even after I told people. All right? Now, this is the square I told you you might want to copy down. You might want to have somewhere. Somebody asked me, are you allowed to use that on your exam? Will I give that to you? No, I won't. But maybe it's something you might want to put on your note card. I don't know. Excuse me. So, we're going to use this scale to help us out with our calculations. So we're going to start. I want you to copy this into your notebook right now, and then we're going to start answering some of these questions. The first thing I'm going to ask is I'm going to say, okay, I have a pH of 1.55. How many sig figs do I have there? Two. Okay? 2 sig figs because it is pH. pH is logarithmic, so only after the decimal counts. Now, I need to find the hydrogen ion concentration. I have the pH given to me, and I want to find hydrogen ion concentration. Well, based on my pH calculation square, it tells me to use the antilog of the negative pH. So, my hydrogen ion concentration is the anti-log of the negative pH. Well, that's great. That's fine and dandy because I know that the pH is 1.55. So, my hydrogen ion concentration is going to be the antilog of negative 1.55. Now this becomes a calculator deal. So take out your calculators. I'm going to show you how to calculate the antilog of negative 1.55. I want you to look at your calculator, and I want you to find on your calculator the LOG button, the log button. On my calculator, it's the button to the left of the 7. Is everybody able to find the log button? Okay. Now, after you've found that log button, find the button that says 10x. And on mine, it's the second function of that log button. Have you found the 10x? That 10x, ladies and gentlemen, is the antilog button. So what we are going to do this calculation, we are going to take the antilog button of the negative 1.55. And when I did that, it gave me a value of 0.028. 1838, and there's a couple more digits. Did you get the correct answer there by typing that into your calculator? Your calculator does not have that. Give me a second here. All right, so there's my value, 0.0281838. Now, I need to get that into significant figures. We said that I have 2 sig figs. So, if I put that right there, 0.028, that is 2 significant figures. Any questions? All right, now I need to find the pOH. So I'm going to come back to my square here. I'm going to erase this stuff. I've already found pH and I've found hydrogen ion. Now I want to find pOH. Well, there's a couple of different ways I could do this. Number one, I could use this value right here because I'm going from hydrogen ion to pOH right there. But I think it's a little easier to use this blue line to go from pH to pOH, and that's right there. The pH plus the pOH equals 14. So, when I come back here, I know that 14 minus the pH is equal to the pOH. Well, we already said that the pH was 1.55. So when I take 14 minus 1.55, it gives me a value of 12.45 for the pOH. Now, does that value right here, how many sig figs there? Are there 2 sig figs there? Yes, there are. Yes, Olivia. Yes. Okay. pH plus pOH is always equal to 14. Okay. Sarah. Yes, it was back to the original. Yes, sig fig wise, it goes back to the original. I could put 14.00, okay? Now, my final thing here is I'm going to calculate the hydroxide ion concentration. But when I go back to my square now here, I'm going to erase these two things. I've now calculated those three things. So in order to calculate the hydrogen or hydroxide ion concentration, I could use this going from the POH. I could use this going from the hydrogen ion concentration, or I could use this going from the pH. Now, I'm going to do this two different ways for you. The first one I'm going to use is I'm going to use this one right here. And what that says is, it says that the concentration of the hydrogen or hydroxide ion times the concentration of the hydrogen ion is equal to 1.0 times 10 to the negative 14. My OCD is getting me there. 10 to the negative 14. So, if I'm going to solve for this right here, it's going to equal 1.0 times 10 to the negative 14 divided by the hydrogen ion concentration. Now, ladies and gentlemen, I know the hydrogen ion concentration. It's right here. So what I'm going to do is I'm going to fill that value in there, that 0.028. And when I do my math there, 1.0 times 10 to the negative 14 divided by 0.028. That gives me a value of 3.571428 times 10 to the negative 13. Now, I need to have two sig figs. Is OH concentration logarithmic? It is not. So I count that number in front. So my value is going to be 3.6 times 10 to the negative 13th. 2 sig figs. Yeah. What these labels, what you're going to see the labels are going to be is they're going to be molarity, okay, because that's a concentration. So it's going to be capital M. All right. Now, I'm going to show you that's a second way to do this, because I just want to show you that it's going to vary slightly. So my second way to do this is I'm going to take right here, I'm going to take the negative log. Actually, that's the wrong one. My bad. Okay? It's this bottom one, this arrow going here. I'm going to take the anti-log of the negative POH. So, for this next one, I'm going to extend my page, and I'm going to take OH minus equals the anti-log of the negative POH. Well, I have the POH. Let me squeak this up just a teeny bit. It's 12.45. So I'm going to take the anti-log of negative 12.45. And when I do so in my calculator, anti-log of negative 12.45, that gives me a value of 3.54,813 times 10 to the negative 13. So when I 2 sig fig this one, it's going to be 3.5 times 10 to the negative 13. And you might ask yourself, why? Why aren't they the same? Why is this one 3.6 times 10 to the negative 13 and one is 3.5? Well, remember, when we went back up here, that number right there, we rounded, didn't we? If we would have the exact number right there, not a rounded 0.28028, both of those values should be the same. Okay? Any questions? All right. Go ahead and copy this down. We're going to work this one. Okay, we're going to now do this problem. We're just starting off at a slightly different place. So we're starting off with the hydrogen ion concentration. So when I come back to my square, I'm right here. I'm at the hydrogen ion concentration. I want to first go to the pH. So here's what I'm going to use. The negative log of the hydrogen ion concentration. So my pH is equal to the negative log of the hydrogen ion concentration okay, so when I plug in my value, it's the negative log of 7.67 times 10 to the negative 5. So I know my log button on my calculator, so I hit the negative button, the log button, and then I type in 7.67 times 10 to the negative 5th. And when I do so, it gives me a value of 4.11524. Now, I go back and I look. How many sig figs do I have here? 3. Okay? So I need to have 3 sig figs up here, but this is pH. So pH is a logarithm. So what I need to do is I need to have 3 sig figs here. So my correct value with 3 sig figs is going to be 4.115. That is my pH. Now, what was your problem?
Well, I put, instead of log, I put second log.
Then that's the anti-log.
Yeah.
Okay, you did it wrong.
Yeah.
All right, now I'm going to go to the POH. Well, I know that the POH is 14 minus the pH. So if I take 14 minus 4.115, I get 9.885. That is my correct number of sig figs there. And then finally, my my hydroxide ion concentration. I'm trying to find that. I'm going to find that from this. So I'm going to use the anti-log of the negative POH. So the anti-log of the negative POH anti-log of negative 9.885, and with 3 sig figs, that gives me a value of 1.30 times 10 to the negative 10th. My hydroxide ion concentration. That's 3 sig figs, Matthew. Okay. Now, here's one that I have to show you. Copy this one down in your notes, then we're going to work this. This is a problem that you will see on your WebAssign. The problem states calculate the hydroxide ion concentration, the POH, and the pH for the following. Now I look at this and it gives me a molarity of calcium hydroxide. 0.00054 molar calcium hydroxide. Now, the thing about this that makes this different is, can you see that if this would dissociate into the ions, how many hydroxide ions would I have? I would have 2 of them, correct? So, when I'm doing the concentration of the hydroxide ion, I need to take that 0.00054 and I multiply that by 2. The reason is because when it ionizes, I have a concentration of double the hydroxide ions. So when I come up with my value, it's going to be 0.00108, but I can only have 2 sig figs, so that's going to make it 0.0011. Now, once again, POH, okay? If I'm trying to get the POH, I can use the negative log of the hydroxide ion concentration. So negative log of the hydroxide ion concentration, which is 0.0011. So I take negative log of 0.0011, and that gives me a value with 2 sig figs of 2.96. Now, once I have that, pH is equal to 14 minus the POH. So 14 minus 2.96 gives me a value of 11.04 for my pH. Would that be an acid or would that be a base? Matthew?
That would be a base.
That would definitely be a base because it is greater than 7.